recording. My Twitch channel is not up and running yet. Haha. Okay, so here's processing. So you'll recall processing is all about sort of combining programming and visual stuff. And so we're going to be just remembering how do you start a basic sketch, and then what are the commands you need to get a graphics window open. What are some of the commands to make graphics work? How do colors work? How does grayscale work? All that kind of stuff is going to be what we're going to do. We're going to remember some old resources as well that you may have forgotten as well. So here we go. This is our sketch. And, I guess I need to increase the font size. That's something I needed to remember to do. So let's change the font size for myself, just so you can see my demonstration. You guys can keep it at whatever you want. I'll bring it up to 32. Although it does bear notice that if you wanted to change things up in your processing environment, I'm not sure what it is in Windows, but you can go to the Preferences menu, and then you can change up all sorts of stuff. So you can check that out at some point when you're bored. All right, so let's draw a really boring, simple picture. So first of all, in processing, when we start a sketch, I want to make sure everyone does this for every single sketch. In other words, every program, every assignment. I want to make sure that you guys put some comments at the top to indicate your name and block and the date. And you could also go a little bit further and talk about the purpose of the program if you want to. That might be good for like the sketchbook, although for an assignment, we all know what the purpose is because you're handing in your brick breaker project, and it'll be pretty obvious what the project is. But for sure, we all should put in our name. And to make a comment, you can just put 2 slashes, and then you can type in your name, and you can type in the date, and block, what are we, 1-1. Yeah, there you go. And that's where all your programs should start. Every once in a while, someone will hand in a project, and the name won't be on the zip file or something, and I'm always like, oh, who was that who made this amazing sketch? And that'll really help out. So just to remind you, a comment is a part of the program that the computer ignores, and you can type whatever you want in there, and that's a very handy way. You can also type in some code. Let's type in some code right now. I'm just going to type in some random code. It won't actually do anything just yet. Type in ellipse, some numbers, some random numbers. You could even put these comments at the end of a line so that you can kind of annotate your project as you go. And you can remind yourself of things. So that's pretty helpful. There are other ways of making comments, by the way. Here's one of my favorite ways. If you have a whole bunch of lines of text, you can select them. So I'm just going to, you can use the mouse or however you want. I'm using Shift arrow key. And then you can press Control / and just comments out all that stuff. And if you press that again, Control / it uncomments it. So this is really handy for, especially when we're programming to like block out some commands that you think might be wrong, or you just don't want to use them right now. You can just kind of block out bunches of text. But comments at their heart are designed to be messages to people who are reading your code, which includes yourself as well. All right, so skill testing question. How do we get started on a project? No, actually, that's not true. I shouldn't say that because oftentimes we're going to use animation and stuff, and that requires something a little bit different. But on a basic project, how do we... Hey, look, I'm in the future. I just realized I'm in 2018. What's going on there? Looking forward to next year, apparently. Let's change that up. So how do we open up a graphics window in processing? What's that command or a function is the way to describe it? How do we make a window of certain proportions show up where our pictures and animations and games will appear? Anybody remember? Just call it out. If you don't remember, that's okay. Maybe it's Tuesday morning. Only thing worse than Monday morning is Tuesday morning. That's like the worst morning of all. Wednesday morning's all right. Tuesday morning. It's size. You got it. Thanks. So you type in size. And then, like all functions, you put in some parentheses and then some numbers. So any function in processing looks like this. It's going to be some name and then parentheses, and then you're going to end with a semicolon. Every line ends with a semicolon. If you forget, it'll be happy to remind you. And then inside these parentheses, this is space for you to put in what are called parameters. And the various functions require specific parameters. So what are the 2 parameters for the size function? I see people like mouthing it quietly to themselves. Share out loud with boldness. What's that? Width and height, you got it. Thanks, Dan. So yeah, you could type in the number of pixels you want your project to be in terms of their width as the first number and height as the second number. So good old 400, 400. I'll make it tall. Make this one tall. 400, 600. And so what we've done here is we're going to open a window that is 400 wide, 600 tall. So height is 400. Height is 600. Width is 400. All functions work that way in processing. It's always a name and then parentheses and then some numbers inside. And the first number of size is always width. And the second number of size is always height. And that's just how this is going to go. All right, so if we wanted to check and see how we're doing, we can go ahead and run our sketch. So running our sketch is as simple as pressing the play button. I'll zoom in. There we go. Just above our currently unnamed sketch, there's a run button. Unfortunately, can't quite aim it there. A wonderful student gave me a laser pointer a couple years ago. I've never used it. This is the first time in this classroom. There we go. That's it. That's the play button. Oh man, I felt good using a laser to teach. Clearly your education was enhanced greatly. That play button there will run the sketch, and if there's mistakes, you'll find out, and if there's not, it'll run. So here we go. Look at that. Whoa, graphics window. There it is. And it is the dimensions that I asked for, taller than it is wide. If I had made a mistake, here's what would happen. Let's say I left off the semicolon. That's a classic one. Oh yeah, actually, I guess I have inline error checking right now. So it'll just automatically kind of inform you as you program what your mistakes are. I forget, do we have that turned on your computers? Yeah, we do? Okay, so then you'll just, as you make mistakes, it'll just highlight them. Kind of like in Word, when you're typing a Word document, you know how it like underlines spelling mistakes and that kind of stuff as you go? So it'll be sort of like that. But if you did run and you were like, oh man, what were the problems? Then down here at the bottom, I guess the laser pointer is pretty bad for the YouTube video, gotta say. They can't see my laser pointer. I guess I'll just gesture with the mouse. Down here at the bottom, there's what's called the console. And we can zoom in, and we can see that there's some error messages. There's also a black space down here that we'll talk about. You can click on errors, and it'll give you a little bit more detail on the errors. Darn you, Doc. So it says missing semicolon. Oh, that's pretty accurate. But in your experience, everybody, can you trust the error messages too much? Not really, right? Like they'll give you some pretty wild error messages from time to time. And they'll mislead you when we have multiple tabs, what tab it's in, and all sorts of stuff. So you are going to have to use your smarts and your experience as you go to sort of figure out what might be going wrong. So that's opening our window. So now how about drawing stuff? So there's a whole bunch of functions for making different shapes, and we'll talk about what those functions are. I'll remind you where you can find a list of all the functions in processing. We'll talk about how you can change the colors. And we'll also talk about the layering of these things, because that's pretty specific. So if I go to, just get out of here. If you want to find a list of all of the things that you can do in processing, I guess you can't see because it's getting cut off at the top. But under Help, you can go down to Reference. Here it is, Reference. And if you click on that, it'll open up a web page. And this is a list of all of the functions in processing, every single one, not including all the libraries you can download and attach, like minim and that kind of stuff. But these are all the great functions. And right here, 2D primitives, this is where we'll start. This is a great list of all the types of drawing stuff you can do. So you can draw arcs, ellipses, lines, points, quads, which are four-sided shapes, rectangles. Oh, I guess that's also a four-sided shape, with 90-degree angles in the corners, and a triangle, which I'm sure you are familiar with. So those are with those things, you're able to produce a surprising amount of interesting graphics. So let's draw one of those. Which one should we draw? Let's draw ellipse. And by the way, feel free to click on any of these to get a little bit more information. They show you examples, and they tell you what the different parameters mean. So the first parameter means the x-coordinate of the ellipse. The second is the y-coordinate. And then the third is width, and fourth is height. And you'll just kind of get used to these things. Okay, here we go. We're going to draw an ellipse. I know, when you woke up this morning, you were like, yes, ellipses, again, are in my life. Let's do it. Ellipse. I'm going to put it at x, 0, 0. And I'm going to make it 300 by 200. So that means its coordinates are these, and its width is that, and its height is that. That's just the pattern of the ellipse function. When I run this, some of you will be surprised that it's not in the center. It's actually going to end up in the corner. So that's something to learn about processing's coordinate systems. They're not the same as in math. So this is going to be annoying for those of you, especially who are new to processing, but I'll show you a great visual that will remind you this. And this is on the course, actually this is on last year's course webpage. So if we go to my website, lordbing.net/compsci, and go to beginning programming, there's a great little video, sorry, not video, there's a great little picture that demonstrates the difference between the coordinate systems. So in math, you're used to this, where you have an x-axis that goes across and a y-axis. The center is 0, 0. As you go up, y increases. As you go down, y decreases. So that's not how it is anymore. In processing, 0, 0 is always the top left corner of your sketch. And this is going to be really important because in order to draw anything or to make anything move around, you're going to use coordinates. So this is super important to understand. The x-coordinates, or the x-axis, still works exactly the same. As you go to the right, x-coordinates increase, and you go to the left, they decrease. But check it out. Oh, what? As we go down, y-coordinates increase. And this is going to be no end of sorrow as you get used to this, especially if you're really good at math and have intuitively built that into your mind. So this actually is the way all computer graphics work because they're trying to eliminate negative numbers, mostly because that takes up an additional bit of storage in the number to store the negative sign. And so long ago, they decided they would make this the coordinate system for computer graphics. So there you go. Let's go back to our sketch. So let's think about this. If I wanted my, sorry, let me get my window open. I want my circle to be in the center. What are those coordinates going to be if my window is this big? What are those coordinates? Yell them out. 200, yep. 300, you got it. So that means we're going to go halfway across and halfway down from our width and height. And if I run that, we'll get our ellipse in the center of the screen. There we go. So going to be annoying for a lot of you as you get started with processing. So you can experiment with the other ones, triangles, quads. I won't go into those details to remind you about those things, but I do want to remind you about two properties that most of the shapes have. They all have an outline color. What's the name of the outline color? All you veteran processing users? Stroke, yeah, thanks. It's the stroke. And the inside color is called the fill. Yeah, the fill. You got it. So we have stroke and fill. And we can control those separately. And you can also make them invisible as well. So if I wanted to color this ellipse, I have to specify the stroke and fill color first. They have to come before. And they will apply for every shape that I do afterwards. So in order to specify, say, the stroke, so we use the stroke function, and this will specify your color. By default, you need three numbers to specify any color: the red, the green, and the blue value. And so you're going to have the three parameters. And if you're like, well, what makes pink? I don't know. I wanted a pink circle. Well, if you're at a loss and ever wondering what are the numbers I need, you can always go to Tools, and you can't quite see it up here, but under your Tools menu, there's a color selector. And you can just move the color selector around until you find the color you want. I want pink. And then you can read off the red, green, and blue values. So 255 for red, 31 for green, 229 for blue. So I'll type those in and get a pink stroke. 255, 31, and 229. And let's do a different fill color. So for fill, I will choose cyan, or whatever color that is. And you can just pick whatever color. You don't have to type the ones I'm typing in. 255, 234. There we go. That's pretty nice. Or it might be anyways. We'll find out. No, it won't be. I can run this now, and I should get a circle that's full of color, and its stroke is a different color. Woohoo! How about changing the thickness of the stroke? How do we do that? Stroke weight. Thanks, Owen. Yeah, so we could type in stroke weight. And actually, this is a little bit tricky, this one. There's a capital W in stroke weight. And if you recall, in processing, all functions and everything you do in processing is case sensitive. So in other words, if you type in the wrong capitalization, it doesn't recognize the command. So if you tried to type in ellipse with a capital E, for example, it wouldn't work. So stroke weight, you can specify the thickness in pixels. So I'm going to say 10. And go ahead and run that now, and sure enough, we get a thicker stroke. And the fill is still that. How do we color the background, everybody? Background, yeah, there's a background function you can call. I like to put that at the top, just above size. And then you could do the same kind of stuff for background. You could type in a number. If you just want a shade of gray, you can just type in one number. So does anyone remember what white versus black is? Black is 0, and white is 255. And then if you want some shade of gray, it's just a number in between there. If you want it closer to white, make it a bigger number. Closer to black, make it a smaller number. So I'm going to put in a black background. So there we go. The background is going to be black. The stroke and fill are set up, and stroke weight set up. And here we go. Oh, that beautiful picture. That beautiful picture. Okay, so we're getting the hang of things. What happens if I type in a triangle next? I'm going to do a triangle. Triangle requires 6 numbers, an XY coordinate for each vertex. So that's a lot of typing. So actually, I kind of regret doing triangle next. But that's okay. I'll just type in some random numbers here. We'll do 0, 0, 0, 600, and 200, 300. So in a triangle, each of these is a XY pair for a vertex. And if I run this, I'll get a triangle. Will this triangle be on top or below the ellipse? Will it be over top of the ellipse or underneath the ellipse? Well, let's find out. It's going to be on top. Oh, man, that triangle. Oh, my art is unparalleled. So this is... The important thing to learn here is not how bad my art skills are. The important thing to learn is that the order of your functions determines the layering of your picture. So if I wanted the ellipse on top of the triangle, I would have to move it down. So I'd have to make it go down to the next line. So now the triangle comes first, and then the ellipse. That means the ellipse will be on top. And now we have an equally ugly drawing, but it demonstrates the ordering matters. The ordering will determine what's on top of what. How do you guys feel so far about all this stuff? This is coming back to you? And for new people, is this going too fast, or are we doing okay? Doing okay? Yeah? Okay, fantastic. I guess I will, I will let you mostly just experiment from here on in with the different shapes. Those of you who are old pros, you could probably just jump into making a beautiful picture, or making a picture. Anyways, maybe not beautiful, or maybe it will be beautiful. For those of you who are new to the course, you'll especially want to visit the resource page, or sorry, the reference page, and just look at those options. And maybe from last year, if you've never used one of these, like maybe you never used point or arc, maybe give that a try in your drawing just to see how they work and see what you can do with it. And just try all these different things out and see if you can use them. I'm hesitating whether I want to go over RGB color mode versus HSB color mode. I think I'll leave that for the end of class if we have some time for that. There's also things like rect mode and stuff that we can talk about maybe at the end of class that will be useful but not super important right now. So here we go, folks. Here's your challenge. Now that you have a little bit of refresher of how this works, I want you to pick a picture of nature. Any picture of nature. You could just search up mountain or desert and take a look. No, you can't. You can't just load the picture. You have to use the drawing functions to draw it. Although, if you want, you could load that in the back as your background, draw your picture on top of it, and then take the picture away at the end. And I'll never be the wiser. So that would be fine by me if you want to use some tricks. But here, look at this picture. That's pretty cool. How could you draw that in processing, as an example? Here's a great one. Or, choose whatever you want. If you want a bit of a challenge, if you're like, Mr. Pelletier, please, I could do this in my sleep. I did it in my sleep this morning, in fact. Here's my project already. Then I would suggest choose a picture with a starry night background and have it generate the stars procedurally. So have some kind of loop that generates the stars, give them a random spread across the sky, and give them a bit of randomness in terms of their size as well. So instead of saying point, this coordinate, point that coordinate, and typing in 1,000 points, use a loop and generate the background, and then draw some picture on top of it, like a mountain or something beautiful like that. Mostly, what we're doing today, folks, is we're just getting our feet wet again, just kind of getting back into programming and processing. And it's a bit of a fun activity. I hope you find it fun. If you don't find it fun, then change it up. Change the parameters of the assignment. But just draw something with it. And then I'm going to be coming around and just admiring your beautiful pictures. And especially giving some attention to people that are new and making sure that they're doing okay. All right, so go ahead and get started, everybody. I'm going to stop this video. Just give me 1 second.